And we're good. Alright, a particle is projected with a speed 10 meters per second at an angle tan inverse 3/4 to inclined plane, which makes it an angle tan inverse 5/12 at the horizontal. Find the range r in terms of g. Show after 2/5 of the time of flight, the distance along the line of the inclined plane through which the particle has travelled is 28/55r. So look, what I'm going to do is I'm going to prove the generic. Do you know what I mean by the generic formula? The generic would be, I think we call the plane was usually beta, wasn't it? The angle of throw was alpha, and the speed was u. So I'm going to go through my 4 formulas using the generic terms, okay? Then I'll modify them. So first thing we're going to look at is gravity. Okay, so what I do is I'm making a gravity triangle. I can do it anywhere on the inclined plane I want. To do a gravity triangle, I draw one of them going straight down, and then I have to draw a line perpendicular to the plane, and then a line parallel to the plane. And then I have to figure out what is this angle in here. What is this angle in here? Usually, it's the angle of the plane every time. However, if you were to forget that, that's a 90-degree angle. That means that this one here is 90 minus beta, and this here, if you look at it, is a right angle triangle, there to there. This part here is a right angle triangle, so that end result would make that beta. That's if you forget. Okay, there's always a way of proving it. Now that you've done that part, what you're looking at next is you're looking at breaking up gravity into its 2 components. Gravity going directly down. This is the adjacent side, which would mean g cos b. This is the opposite side to the angle beta, which means g sin b. Okay. Next thing you have to do after you do your gravity triangle is you're going to do your u triangle. You're breaking up u into 2 components. You're breaking this throwing speed into a component parallel to the plane and perpendicular to the plane. Once again, we'll call this angle alpha. Call that u. Makes the opposite u sin alpha. Makes the adjacent u cos alpha. Okay? And now you're ready to make your formulas. So we're going to get phi x. Now phi equals u plus at, and s equals ut plus a half at squared. We'll start off with phi. Phi along x is what, guys? Anybody? Along the x direction? This direction here? U cos alpha, perfect. And gravity? Yeah, this one here. This gravity is going along this line here. So it's minus gt sin b, because it's acceleration times time. So g sin b multiplied by t, gt sin b. That's phi x. Phi y, we're looking at what's going directly up from the plane. Perpendicular to the plane is u sin alpha. And then minus gt. And what's going straight down into the plane? What part of gravity is going straight down into the plane? The answer's in here. G cos b. Now, we're going to change to the S formulas, which is Sx and Sy. So, what about Sx, guys? Same thing as this one here, except add on a t. Ut cos alpha. Same thing as this one here, half it and add on another t. So minus gt squared sin b. Same deal with phi sy and sx, add on a t, we get ut sin alpha, and then minus a half gt squared cos beta. Is everybody happy with how to make those formulas? That's what we would have done the last day. You had 3 questions on that, okay, and it's the same stuff. Now, once I've done that, I can now remove all these workings. These workings that's how you get your generic formulas, okay? Now, once you've got your generic formulas, what we're going to do next is we're going to modify the generic formulas to suit our question, okay? So, to suit our question, they're all going to go up here, and now we're going to modify them. So, let's find out let's find out the two angles for us is, okay? So there's just two angles here. The two angles are tan, this is A and that's B. So for the angle A is in a opposite is 3, adjacent is 4. What does that make the hypotenuse? 5. And that therefore makes cos alpha 4 over 5 and sin alpha 3 over 5. Same deal with the beta triangle. The beta triangle is going to be 5 is the opposite, 12 is the adjacent, and the hypotenuse 13. Therefore cos beta is 12 over 13, and sin beta is, what is sin beta? 5 over 13. Modify your existing equations with your new information. And we know that u equals 10. So we have a lot of numbers to plug in. So for phi x, it's going to be 10 times. What's it going to be? 10 times 10 cos alpha. So 10 times 4 over 5, which is 8. So just get rid of that. Put in the 8 minus gt sin b. Sin b is 5 over 13. So minus 5 over 13 gt. Okay. What about phi y? Phi y, u sin alpha. U sin alpha is going to be 10 times 3 over 5, which is 6. Minus gt cos b is going to be minus, what's it, 12 over 13 gt? Okay. Sx, anybody? What's the general rule here? Look at phi x, add on a t, so it's going to be 8t, half the fraction or whatever number comes in front of gt, so it's going to be 5 over 26, yeah? And then put a squared onto the t, gt squared. The next one then, sy, put a t behind the 6, half the fraction, 12 over 26 is the same thing as what goes 6 over 13, right? 6 over 13 gt squared. Okay, there's our 4 formulas. Anything else that you've done before that? No longer really matters. Now, what are we finding? What is the question specifically asking us? Only now that we have our setup in place can we actually make it to the question part. Find the range. What does that mean? Find the range.
SX.
Sorry?
SX.
So we want to find the SX value, which is denoted by the, we'll do a green line. There you go. We want to find this. This here is the range. It's an SX distance. What happens when your particle hits the ground here? What value is 0? Sy equals 0. You have no height above the plane when you hit the ground. That means Sy equals 0. Now we're just going to run a check today. Do you remember that? Remember when we used to get phi y equals 0 at the top of the range? And do you remember that Sy used to be double? The time for doing Sy equals 0, it was double the time taken for phi y equals 0. We're just going to check that out. We're not asked to do it. We just want to make sure everything's still as it was. Okay? So what we're going to do is, first of all, to answer this question, I'm going to get Sy equals 0, which is going to be 6t, 6 over 13 gt squared equals 0. So, factorize out 6t into 1 minus 1 over 13 gt. 2 times in question, t equals 0, or 1 minus 1 over 13 gt equals 0. This will mean that t equals 113 gt equals 1. T equals 13 over G. We might as well put that into 13 divided by 9.8. What's 13 divided by 9.8? Uh, 65 over 49, okay? So T equals 65 over 49. Happy enough with that? Now, just let's check that this still works for inclined planes, alright? Remember we said phi y equals 0? So phi y equals 0 is what, guys? 6 minus 12 over 13 gt equals 0. Bring the 6 over here, so 12 over 13 gt equals 6. GT, T equals, what's this going to be? It's going to be 13 over 2G. Does that still work? It's basically half of what the sy equals 0 time is. So basically you still have your choice. You can find sy equals 0, find t, or you could have done phi y equals 0, find t, and double your answer, and you get 13 over g, which is the same thing we have here. So both options are still available, whichever one you find easier. Okay? Now that we've done that, we now have to find the range. How do you find the range once you know the time, lads? What type of distance is the range? Is it an sy or an sx? It's an sx. An sx, 88 times whatever my time is, which is 65 over 49. I need somebody on the calculator for this, please, if possible. 6 over 13 multiplied by 9.8, and then 65 over 49 squared. In terms of g. Okay. Always read the question properly. In terms of g. Quick fix. Instead of using 65 over 49, I'm going to use 13 over g. So I'll just get this here.
Yes, so that isn't 6 over 13 either.
What'd you say?
That's on the sy, 6 over 13.
Oh, 6 over 13 is the sy. I'm looking for the sx. Excuse me. So the sx is 5 over 26. Thank you very much. And it's 13 over g. So we have here is 13 over g. G times 13 over g squared. So if somebody would multiply 8 by 13 for me, 112, is it?
104.
Well, 104. I think we go back to bed. Now, next one is what's 13 squared? 169. 169 multiplied by 5 over 26. Anybody?
65 over 2.
65 over 2. That's gone, that'll do me. And then it's going to be g divided by g squared, which is, because g is here, and when you square this out, you're going to get 169 over g squared. So g divided by g squared is g. So we have this at the moment. Let's give them a common denominator, which is 2g, multiply the top and bottom by 2. Can anybody tell me what 208 minus 65 is?
143.
Sorry?
143.
143. Okay. 143 over 2g. And that's my sx. Continuing on with this, it says show that after 2/5 of the time of flight, the distance along the inclined plane. What does along the inclined plane mean? An sx distance. Not above the inclined plane, along the inclined plane. Find the sx distance at t equals 2/5 the time of flight. So we work our sx formula. Anybody remember the sx formula is? It's going to be at minus 5 over 26 gt squared. It wants a time of flight, or time, that's 2/5 of 13 over g. You happy with that? 2/5 of 13 over g, which is 26 over 5g. So the time I'm going to put in here is 26 over 5g. So I'm going to find out the Sx, which is going to be 8 times 26 over 5g minus 5 over 26g times 26 over 5g squared. Okay, this is going to be a bit tricky. 8 times 26, anybody?
208.
Thank you. 5 multiplied by, oh wait. Yeah, this is going to be a difficult one. So we put this in the calculator. 5 over 26 multiplied by 26 over 5 squared. Might be a tricky one for the head at this time in the morning.
Minus 26 over 4g.
Okay.
Or over 3g.
Yeah, I think you got that. Still 26 over 5?
Over 5g.
Yeah. And that's a g divided by g squared, which is over g. They both have the same denominator, thank God. So 208 minus 26. 182 over 5g. So that's the distance we spent, that's the distance we travel along Sx with 2/5 of the time. Now, it wants us to show that it's this fraction of r, 28 over 55. So, if we get a distance, if we put this distance divided by the range, it should give me the fraction that it is. So, an example would be if I travelled 100 metres of a 200 metre range, and I divide my distance travelled by the actual range, you'll find out that's a half. So hence it's a half of the range. So what we're going to do is we're going to get the distance we just travelled for 2/5 of the time, which is 182 over 5g, and we're going to divide that by the range, which is 143 over 2g. So ignore the g's, they're going to disappear. You can bring the top fraction to the, you can bring this fraction to the top, turn it upside down, and you get 2g over 143. Would somebody tell me what the fraction turns out to be? 182 multiplied by 2 divided by 5 multiplied by 143. What do we get? Thank God. Right, 28 over 55 r. Okay.